Alright guys, welcome back. So in this video we're going to talk about how do we solve a differential equation by separation of variables. And today we're going to talk about a particular part of that, which is finding what that value of c is, or a particular value of c. So for example, we're going to start with the problem. So I'll tell you dy dx equals 2x y squared. And I'm going to ask you to find what's called the particular solution. So last time we found the general solution, but now we're going to find the particular solution with some kind of initial condition. And in this case, let's see, it's y of 1 is equal to 2. So this is saying like this y of 1 equals 2, that means when x is 1, y is 2. So it's saying you have the point 1 comma 2. And that point is actually going to be enough to give us a value for c, just like with usual integrals. Okay, so when you see this particular solution, again, they're just basically telling you to find an equation for y, solve for that. So let's go ahead and do that. So we're going to start and basically go through the same steps, just with one new part today. So again, the same steps for separation of variables. We separate, we integrate, and then we solve for y. Every separation of variables problem follows the same three steps. So we'll divide out the y squared, we'll multiply the dx to the other side. Great. And now we're going to slap both sides of this with an integral stick. Okay, so the integral on the left is integral y to the negative 2, so that's negative 1 over y. On the right, we put the x squared, and again, we just put the plus c on one side, make the x side easier here. Okay, now, there are multiple ways you can proceed. But this is what I'm going to recommend. Right after you integrate, this is where you want to plug in to solve for c. So you're going to take this point, we're going to plug in that point that was given, we're going to plug in that 1 comma 2 that they gave us right here, and use that to help us find the c. Now, you can wait until you solve for y, but the problem is you're going to have to unpack the equation to get the c by itself. Right now, the c is just chilling out here, ready for the taking like an apple in the Garden of Eden. So let's just go ahead and plug in that 1 comma 2. So we're going to get negative 1/2 equals 1 squared plus c. Okay, so we'll subtract the 1s, and negative 3/2 equals c. Great. Okay, so now what I'm going to do is I'm going to plug that c back in and finish solving for y. So I took a little detour now. I'm going to take the c, plug back in there. So negative 1 over y equals x squared minus 3/2. Okay, and now when I want to solve for y, we can just do what we did before, maybe multiply by the y first, and then we'll just divide by the new part here. So my y is negative 1 divided by x squared minus 3/2. So again, this is the same thing we've been doing, but now that we have this initial condition, this allowed us to find a c. And this is interesting because this is actually unique. So again, this is a solution. So if you were to take this y value and plug it back in this differential equation, the derivative would just be 2x times that y value squared, but it also goes through this point 1 comma 2. So that's what we're trying to find. The equation that satisfies the differential equation, but also has this specific point on its curve. Okay, and basically this is like a saying, it's an equation for the solution curve that goes through that point we just had, that goes through the point 1 comma 2. That's what we're finding, the equation for the solution curve that goes through 1 comma 2. Okay, so what we're going to do next is another example. This one's going to have a little bit of a kink. So we're going to solve this by separation of variables. And there are different ways you'll see these problems phrased, but you're doing them all the same. Solve by separation of variables to find the equation for y equals f of x. And you're going to be given a specific point that f of 0 equals negative 4. Okay, and this one's going to have a little bit of a kink in the plan. So dy dx is e to the negative x plus 2 divided by y. All right, so we'll separate, we'll multiply the y and multiply the dy dx to both sides. So we get e to the negative x plus 2 dx. Okay, so again, we're going to slap both sides with an integral stick here. So we'll get y squared over 2. Something interesting is going to happen because of the y squared here, but let's go ahead. Okay, so just briefly, if we want to integrate e to the negative x, maybe do a little u sub over on this side, right? So be careful with the constants. U is negative x, the derivative of that is negative 1. Oh no, negative 1 times dx. Okay, so when I plug that in, I need a negative here and a negative in front. So it's negative integral e to the u, so negative e to the u. So that becomes negative e to the negative x, and then plus 2x. Of course, you can check your answer there. If you want taking a derivative, okay, it works out. All right, so just like before, my initial point here was 0, negative 4. The f of 0 is just like the y is 0, same thing. So we're going to plug in the 0 minus 4. Okay, so negative 4 squared over 2 is 8 equals negative e to the negative 0 plus 0 plus c. So 8 is negative 1 plus c, so my c value is 9. All right, so again, we'll plug that back in. Y squared over 2 equals negative e to the negative x plus 2x plus 9. All right, well, first thing we got to do now is multiply by the 2 to both sides. So I'll multiply both sides of the equation by a 2. So I'll get y squared equals negative 2e to the negative x plus 4x plus 18. Okay, now, of course, we take the square root, but the square root is going to lead to a plus or minus. Now, the good thing is, don't give up, don't despair. We can actually figure out whether it's plus or minus, and this is great. So to determine whether this is plus or whether it's minus, and I know this seems weird, but we're going to do this again. We're going to plug in that initial condition, 0, negative 4, again. So as you know, these problems are a little bit on the long side, but I think you'll enjoy them. So we're going to plug in the 0, negative 4 again. So we're going to get negative 4, that's my x, my y. Negative 4 equals plus or minus square root negative 2e to the 0 plus 18. So I get negative 4 equal to plus or minus square root 16. So then once you plug this in, the way you determine whether it's a plus or minus is you just kind of ask yourself, really, which is it? And this is always going to be a very easy step once you plug everything in, right? Is negative 4 equal to positive 4? Or does negative 4 equal to negative 4? Well, you have a brain, so you're going to say it's the negative one right there, right? So what that means is negative 4 equals negative 4, not positive 4, so that's what we want. So that means we want the negative in my equation here. So that means we're going to use the equation y equals negative square root negative 2e to the negative x plus 4x plus 18. We need that minus in front. Okay, and there's our solution. Okay, so I'll just try one more really quick. Maybe you can try this on your own. So let's say dy dx equals x cubed square root y, and you're given that y of 2 is equal to 1, and I ask you to find the particular solution. Maybe go ahead and pause the video and try and do that problem on your own. Okay, so we're going to get dy over square root y equals x cubed times the dx. So we integrate both sides. So the right side is pretty easy, x to the 4 over 4 plus c. On the left, you're integrating y to the negative 1/2. So we add 1 to the power, so y to the 1/2, and balance in front. Again, we just always put the plus c on that side. So again, when we see y of 2 equals 1, it's saying when x is 2, your y is 1. So it's 2 comma 1. So we're saying 2 times square root 1 equals 2 to the 4 is 16, so that's 4 plus c. So my c value is negative 2. So then we'll put that back in. Again, your life is just way easier finding the c now than trying to like bury it from within the square root and kind of unearth that. Much easier just to find c right after you integrate. I will always recommend that. Okay, so now we have 2 rad y equals x to the 4 over 4 minus 2. So we'll divide the 2 out by everything. Okay, that's cool. So rad y equals x to the 4 over 8 minus 1. Okay, and then we just square both sides, right? So y is x to the 4 over 8 minus 1 squared. Okay, yeah, hopefully I did that right. That looks pretty good to me. Okay, so that's separation of variables and finding a particular solution. What we've done before, just the new step of plugging that point in to solve for c. Okay, one more just note, and this is something that's not going to come up a ton in our class, but will come up beyond this class. Not all differential equations can be separated. Remember that when we separate something, we can only multiply or divide. Adding and subtracting are going to get us into trouble. So for example, if I give you a differential equation, like even something that looks simple, like dy dx is x plus y minus 3. This is something that's actually going to be impossible for us to separate. Like, this is something, even though it looks simple, separation of variables is not the strategy here. Like, let's look y. Maybe you try and get the y on this side, right? dy dx equals, so maybe you try and like subtract the y, and that equals x minus 3. And then, but look what happens now. You multiply the dx to both sides, and then you get, okay, so I get dy minus y dx equals x minus x minus 3 dx. So no matter what you have, you got this y dx that are kind of entangled. So this is something you can't separate. Again, this isn't going to come up much in this class, but I just want to show you that not everything can use separation of variables on. Okay, thanks for watching, guys. That's particular solutions finding C. Key stuff here. Bring me some questions to class, and I'll be happy to help.